Answer is no. So I am going to run router rip. And guys, after running this command, if you will check, so IP protocol. After running this command, if you will check, so IP protocol. Is any protocol running? No. Why? Because as I told you, RIP or any routing protocol will work on interface of router, not on the router. So with the help of this command, actually we are allocating memory to the protocol, right? So I need to advertise router RIP. I need to enable RIP on the interface. So I will use network command, network 12.1.1.0. So this command will enable RIP on F0/0. Here I am running this network 12.1.1.0/24. Here my network is 23.1.1.0/24. Here my network is 14.1.1.0/24, and here my network is 24.1.1.0/24. You can configure /30 as well. So either I can run this command or I can simply say network 0.0.0. So this command will enable RIP on all interface. Done. So now you can see, so IP protocol. Which routing protocol is running? RIP. See how you will read the output. So first thing is, guys, routing protocol is RIP. Routing protocol is EIGRP, OSPF, BGP, like that. These two are for filtering, right? So we'll talk about filtering later. Don't worry about it. Now next, update message. Sending update message after every 30 seconds, right? So update timer is 30 seconds by default in the RIP. If you want to change it, you can change it, right? You can configure 100 seconds, but it will always send periodic update. So how we can debug IP RIP? We can use this command to check. So see, it is sending update message, right? And guys, how many networks are there in the update message? 10.0.0.0, 13.0.0.0, 10.1.1.0, 10.1.3.0, 13 and 14. Why 14? Okay, we have 14 network as well here. And router 3 is going to learn how many network from router number 1? Router 3 will learn how many network from router 1? 10 and 40, right? Actually this is 13 network, not 12 network. Let me correct it. 13. Now I am going to enable RIP on router number 3. So let me access R3, and here also I am going to say router RIP, and network 0.0.0. So IP route RIP. So IP protocol. Routing for 0.0.0. So IP route RIP. Router 3 is learning how many network? 2 network. So actually router 1 have summarized all 10 networks together. Simply I can do one thing on router number 1. First of all, let me disable the debugging on all and config T. See, in RIP version 1, by default automatic summarization is enabled. And guys, RIP version 1 is class full routing protocol. Class full routing protocol means it will always advertise network with default CIDR value. So this IP address, this network belongs to which class? This network belongs to which class? Class A. And what is by default CIDR value for class A? 8. Right? So as RIP version 1 is class full routing protocol, so it will always advertise network with default CIDR value. So all networks will come under single network, that is 10.0.0.0/8. So that's why it is advertising only single network. But here I can say please enable version 2 router RIP and then say version 2. Now go to router number 3, say clear IP route star and show IP route RIP. Just wait for some time. After 30 seconds it will receive one update message and then it will learn all prefixes. But issue is on the router number 2 we are running version 2 and router number 3 RIP version 1 is running, right? So both version are not compatible with each other. So on router number 3 also you have to change version. Say router RIP and version 2. Now show IP route RIP. Still we have class full network, right? Network with default CIDR value. So on router number 1, now I am going to say disable. I am going to disable automatic summarization. See what is happening. So IP protocol. Guys, automatic network summarization is in effect. Means automatic summarization is enabled. Summarization means see, subnetting means what? Subnetting means dividing large network into multiple smaller network, correct? Means dividing large network into a smaller network is known as subnetting. And combining multiple smaller network into a single large network is known as summarization, right? So router 1 is by default summarizing these all network into a single network. Right now there are two types of summarization. One is manual summarization, that manually you can summarize these network. Let's suppose on router number 1 we have 100 number of networks, but what you want that router, let's suppose router 3 cannot handle 100 number of route in their routing table. So manually we can summarize these all network, all 100 number of networks together, right? Maybe into one network or into two network, then we can advertise it to router number 3. So we come up with summarization technology to reduce the routing table, size of routing table. Like you can see router 3 have only one entry for these all 10 networks with the help of summarization. So summarization is useful to reduce the size of routing table. But RIP perform automatic summarization, that is manual summarization. Manually we can summarize it. How you can summarize these network together? How you can summarize these three network together? See, first of all I will find where is the change. So change is in third octet, am I right? Change is in third octet, so I will convert value of third octet into binary. So binary of 1 is, guys, this one, then binary of 2, then binary of 3. Now tell me how many common bits are there. Five bits are common, right? So summary network is going to be what? Slash 8 plus 8 plus 5, 21. Now question is what will be the network ID? So here you need to perform AND operation. Here you will perform AND operation. So after the AND operation I will get all 0, yes or no, and decimal value will be 0. So guys, my network is going to be 10 dot, sorry, 10.1.0.0/21. This is what summary address of these three prefix, right? So this is manual summarization, and automatic summarization means it will summarize to class full network, right? Means it will use /8 for all 10 networks. It is going to use /8. So single network will be 10.0.0.0/8. Voice, do you have issue with my voice? Hello, is it okay now? Is voice breaking? No? Okay. So see, by default automatic summarization is enabled over here. So I am going to disable it. Simply command is router rip. Now whatever command you are going to run for rip routing protocol, you will run that command under router rip. And here I am going to say no auto summary. This command will disable automatic summarization. Now if you will check so IP protocol, so you can see automatic summarization is now not in effect. Not in effect. And now if you will check routing table of R3, so IP route rip, you can see router 1 is advertising all individual prefixes. Am I right? Even router 1 is advertising 13 network as well. 13 network to router number 3. But why router 3 is not learning 30 network with the help of RIP? Because guys, 30 network is directly connected. For directly connected, AD value is right, and from the RIP, AD value is 120. So that's why router 3 is going to learn only 10 and 40 network. Let's suppose router 1 is advertising one more network here, that is 50.1.1.0/24. But router 3 have already 50 network in the routing table. Let's say I have configured a static route, right? And here AD value is 5. Then also router 3 will not learn 50 network from RIP routing protocol, right? Because router 3 have already that network information with lower AD value. If here AD value is more than 120, if here AD value is more than 120, then only it will learn through dynamic routing protocol, through RIP routing protocol. See, right now I am not interested to teach you RIP routing protocol, brother. I am interested to teach you dynamic routing protocol, how dynamic routing protocol is working. Like you can see, this router is learning one network 10.1.1.0/24. AD value is 120, metric is 1. Why metric is 1? Because this network is one hop away. Metric in RIP routing protocol is hop count. So this network is one hop away. So that's why metric is 1. But what will happen if I will configure one static route? Here IP route 10.1.1.0 255.255.255.0, and let's say next hop is 13.1.1.1, and here I am going to set AD value, let's say 50. Now do you think router 3 will learn the same network from RIP routing protocol? See, 10.1.1.0 is not there, right? The reason, because this router have already same network information with AD value 50. This router have already a route available with lower AD value. Done. Now I'm going to remove a static route configuration here. Say no to this command. And now I'm going to enable RIP on router number 2. On router number 2 also, I will run network 0.0.0. Say router RIP and network 0.0.0 version 2. And no auto summary. Done. So IP RIP database. It have installed these all network in their database, all 20 network, 23 network, as well as 24 network. Means all networks which are available in the routing table. It have installed all network in their database, right? And now guys, if you will check database now, you can see it have learned 10 networks as well, right? It have learned 10 network as well, but summary network, right? Actually router 3 is summarizing the network, right? Router 3 routing table have all individual prefix, so IP route RIP all individual prefix, but here by default automatic summarization is enabled, so do so IP protocol. You can see automatic summarization is in effect, so that's why router 3 is summarizing all network together. So I can say router RIP no auto summary here as well, no auto summary. And now you can check router 2 routing table, so IP RIP database. Now you can see it is learning all individual prefixes. Am I right? And so IP route RIP. So you can see router 2 have learned these all 10 networks. And see, it is learning 13 network also, 13.1.1.0, 14.1.1.0. So these are unwanted networks in the routing table, right? So later we will see how we will filter these network information, right? I don't want to install these network information because router 2 never going to forward traffic to 13 network or 14 network. So these are unwanted network information in the routing table. So later we will filter it. Ignore it for now. Now can 10 communicate with 20? Yes. Ping 20.1.1.1 source 10.1.1.1. Ping is working. If ping is not working, then tell me the reason, guys, why ping is not working, how you will troubleshoot. But ping is working, you can see here. If ping will not work, then again you are going to check what? ARP table of all devices between source and destination, next hop IP address, routing table, RIP configuration, filtering. Done. So you have two table here in the RIP routing protocol. So IP RIP database. In the database, it will install all networks. See, this router is learning one network, that is 10.1.1.0/24. AD value 120. But if I will configure one static route here with lower AD value, IP route 20.1.1.0, 255.255.0, and next hop IP address is 13.1.1.3, AD value is 50. So IP route RIP. It have removed 20.1, 20.1.1.1. So IP RIP database. Is that network available in database? Yes. Possibly down. So it is going to actually remove this network from the database as well after some time. But all routing protocols are going to store all network information in the database, and it will install only best path in the routing table, right? So IP route. So routing table carry best path and database carry all possible path. Now guys, I am going to enable RIP on router 4. Router RIP version 2, no auto summary and network. Done. Now router 1 is going to learn 20 network from how many side? From how many neighbor? So IP route RIP. On fast Ethernet 0/0. That means till now router 1 have not learned 20 network from router number 4, right? But after some time it will learn. Now you can see. And how many path I have for this network? 20.1.3.0, 2 path. Why router have installed both path in their routing table? Because guys, see the metric, prefix length and AD value, all parameters are same. So if all parameters are same, then router is going to install both path. And if both path is installed in the routing table, then router will perform what? Load balancing. Router is going to perform load balancing in this scenario. Now tell me the problem of RIP routing protocol. Let's suppose here bandwidth is 1 Gbps, here bandwidth is 1 Gbps, here bandwidth is 10 Mbps, here bandwidth is 10 Mbps. Then also router will perform what? Load balancing. Correct? This is first issue, and this is the reason why we are not using it. Am I right? Because router is going to select best path on the basis of metric, and metric is hop count. Distance vector routing protocol does not use link properties to calculate best path. This is the reason why we are not using this protocol. Right? So even you can check it, you can configure, let's say, higher bandwidth on one link. Let's say on fast Ethernet 0/0, my bandwidth is, right, and on F1/0 I am going to configure lower bandwidth over here, let's say 10 only, right? Then also you can see show IP route RIP. Then also RIP is performing what? Load balancing. But upper path is the best path now. Then so you can read some theory of RIP routing protocol here. Like RIP stands for routing information protocol. It is a distance vector routing protocol. It is a layer 7 protocol. Means all message of RIP will be generated at layer 7. AD value of RIP is 120. It use UDP port number 520. UDP port number 520. Then routing information protocol, RIP is a distance vector routing protocol which use hop count as a routing metric. This is the biggest issue with distance vector routing protocol. What is the second issue? Periodic update, right? Debug IP RIP. Periodic update, it is sending. See, all router have already routing information, right? Then also guys, router 1 will be keep sending update message to both router, to router 3 and router 4. So unnecessary it is utilizing the bandwidth. It is using their CPU, right? So this is second issue with distance vector routing protocol. It should not, because see, update message is guys not a small message, because it is sending complete network information. Update message carry all network information, right? All network information means all routing table. So routers are actually sending complete routing table to their neighbor after every 30 seconds. So this is second issue why we are not using it. RIP routing protocol on all. Disable the debugging. Then the largest number of hop allowed is 15. Largest number of hop is 15. So only 15 hops are allowed. So if you have 16 router in the series, then also you cannot use RIP routing protocol. So this is limitation of network size, right? Which limit the size of network that RIP can support. RIP implement the split horizon, route poisoning, and hold on mechanism to prevent incorrect routing information loop. Then guys, we have some timer like update timer. By default update timer is 30 seconds, then invalid time 180 seconds. See the meaning of invalid time. Router 1 have advertised all 10 networks to router number 3. These all networks to router number 3, and router 3 have installed these all network in their database as well and in their routing table as well. But let's suppose now router 3 is not receiving any update message from router number 1. So network informations are already there in database as well as is in routing table. So what router 3 will do? There is one invalid timer running, that is 180 second. Means after 180 second, router 3 is going to declare all these 10 network as invalid, right? And guys, if routes are invalid, then router will not forward traffic for those network. Router will not forward traffic for those network, right? But let's suppose you want to configure the scenario like if router 3 is not receiving any update message from router 1 for 100 seconds, then it should flush all network information from database from the routing table. You can configure, you can manipulate the timers, but by default invalid time is 180 seconds. So after 180 seconds also router is going to carry network information, but it will declare that as invalid, right? So it will not flush the entry. It will flush entry after flush time. So flush time is guys 240 second, right? 240 second. So 0 to 180 second networks are valid, right? And this timer will be reset after every 30 second. See, this is router 2, and on the router 2 update time is 30 second, means it will send update message after every 30 second. Invalid time is 180 second. So if it will not receive any update message from the neighbor, it will declare route as invalid. And flush time is 240 second. If a router will not receive any update message from the neighbor for 240 second, then it will flush all network information from their table, right? So guys, a network is valid for 180 second only if it is not receiving any update message, right? But let's say the router have received one update message from the router number 1, so it will again reset all timer. This time will become 0, this time will become 0, this time will become 0. Again it will start timer, right? 1 second, 2 second, 3 second. After again 30 seconds it will receive the update message, it will reset the timer. If it will not receive update message after 30 seconds, no problem, route is still there, right? This is again one problem. Let's say router 1 is down. Router 1 is down. This is why router 1 is not forwarding update message to router number 2. But if router 2 will receive a traffic for 10 network, it will be keep forwarding for 180 second. It will be keep forwarding for 180 second. So guys, convergence time is 180 second in the RIP routing protocol. Whenever change will occur, topology will take 180 second to converge it. And hold on time is 180 second. Hold on time means like router 1 have learned some network information with the update message, with the help of update message from router number 1. So that network will be valid. That network, router is going to install that network for 180 second in their database, in their routing table. Like you can see in this scenario, see the router 1 database. So IP RIP database. We have 20 network, 20.1.3.0. Let me remove the static route as well. No IP do so run section route. I'm going to remove static route configuration. No to this. Now, so IP RIP database. So we have 20.1.1.0. 20.1.1.0/24 network in the database. What will happen if 20 network will goes down? And guys, this router is learning 20 network from 2 neighbor, right? It is learning 20 network from 2 neighbor, from 14.1.1.4 as well as from 13.1.1.3. So it is learning for 20 network from 2 different neighbor. Or you can check like this also, database like this also. Show me the database for this network only, right? So you can see we have 2 paths. Now what will happen if our network will goes down on router number 2? I'm going to down loopback 1 interface loopback 1 says shutdown. Now network is down, but still see router 1 have this network information in the database. So guys, if router will receive traffic for this network, it will forward to They are neighbor. Now it's saying this network is possibly down, right? So IP route 20.1.1.0 255.255.255.0. It have removed the route from the routing table, but network is still there in the database. In the version 1, even you will see router will have route in the routing table, right? So when router 1 is going to remove this network information from the routing table after 240 seconds. After 240 seconds. Then, so this is also one problem with RIP routing protocol. Again, I am going to up this network. Say no set. And now in the next update message, it will receive this network information. See. So actually what is happening when this network bill goes down? Router 2 will remove this network from the update message. In the new update message, it will include 20.1.2.0, 20.1.3.0. Then it will forward to router 3 and router 4. Router 4 and router 3 will forward it to router number 1. Router 1 will came to know that, okay, now I am not receiving 20 network. But guys, flush time is 240 seconds. So it will not flush entry immediately. It will wait for 240 seconds. Clear? These are theory of RIP routing protocol, and really you don't need to learn RIP routing protocol. Even in the new syllabus, we don't have RIP routing protocol. But it is important to understand dynamic routing protocol, how it's working. And by default, split horizon is enabled or disabled. How I can verify? So IP interface F0/0. See guys, this interface have joined one multicast group. Which multicast group? 224.0.0.9. Remember class D. Class D range is? Class D range is? Yes. So this IP belongs to that range, correct? So this IP, this multicast IP address is reserved for RIP version 2. RIP version 2. Here I am running RIP version 2. That's why it is forwarding update message on multicast address, on this multicast address 224.0.0.9. Got it? That is default, yes, and this is fixed. Even you cannot change the multicast address. Yes, this multicast address is reserved for RIP routing protocol, RIP version 2 protocol. In the same way, we will have one multicast address for EIGRP, one multicast address for OSPF. And is there any information about split horizon? Can you see somewhere split horizon? So IP protocol. You can check the command. What is the command to check split horizon? And command to enable and disable it is simple. On interface, we can say IP split horizon. For EIGRP, generally we are going to use it in EIGRP routing protocol. I will perform one lab on it, right? And guys, if you want to see the capture, you can capture any link. And this is the command to configure RIP. So if you want to use RIP routing protocol in your network, you can use, but make sure you are using version 2, not version 1. Because RIP version 1 send update message on their broadcast address, on the broadcast address, right? So we don't have any multicast address for RIP version 1. And you already know the benefit of forwarding update message on multicast. The benefit of sending update message on multicast over broadcast. Like I have router 1 connected with one switch. Then router 2 then router 3, then router 4. Like on router number 1 I am running RIP version 2, and router number 2 also I am running RIP version 2. So what is the benefit of sending update message on multicast, guys, over broadcast? If router 1 will send update message on broadcast address, then router 3 will also receive it, router 4 will also receive it, and router 2 will also receive it. At which layer router 3 is going to drop it? At layer 4, right? When it will check destination port number. Am I right? In the same way, router 4 will also drop it at layer 4. But router 1 will, if router 1 will send update message on multicast address, that is 224.0.0.9, then again all routers are going to receive the multicast message, but router 3 and router 2 will drop it at which layer? Layer 2. When it will check destination MAC address, destination MAC address is multicast, and this interface is not member of that multicast group. Only router 2 is going to join that multicast group. So when you are enabling RIP routing protocol on the interface, that interface will immediately join that multicast group, right? Once you will enable RIP version 2 here, it will join that multicast group. So to reduce the CPU utilization, we come up with multicasting, right? This is a benefit of sending update message on multicast address over broadcast address, right? So configuration is very simple, and then you can see the difference between version 1 and version 2. So version 1 send update message on broadcast address on 255.255.255.255, but version 2 send update message on multicast address. RIP version 2 is an class full routing protocol, right? So RIP version 1 will always advertise 10.0.0.0/8, right? Will never advertise classless classless networks. Classless means subnetted network. These all are, guys, subnetted network, correct? Main network is 10.0.0.0/8. This is class full network, and these are classless network. Here I am using CIDR value, right? 25, classless inter-domain routing. Done. So RIP version 1 is class full routing protocol, means we cannot use subnetted network in version 1. You have to use class full networks only. You can use 10.0.0.0, but you cannot use 10.1.0.0/16, right? And RIP version 2 is a classless routing protocol. So nowadays we will never use class full routing protocol, right? Because subnetting is most important topic, right, in networking for the segmentation. So everywhere we are using subnetting. But if your routing protocol is class full, then there is no logic of subnetting, right? Because routing protocol is going to summarize it, right? So that's why here you can see this routing protocol version 1 does not support VLSM, or you can say does not support subnetting, but RIP version 2 support VLSM and subnetting. Even in RIP version 1 we cannot configure authentication. So RIP version 1 is an unsecure protocol. We cannot configure authentication, but in RIP version 2 we can configure authentication as well, right? So these are some differences between the version 1 and version 2. Now, guys, drawback of RIP. First of all, hop limit. We have hop limitation. Maximum hop is 15. Then metric is hop count. This is also bad, because metric should be dependent on the link property, right? Not on the hop count. Like, is it true that longest distance is always true, is always good? No. Sorry, shortest distance is always good? No. Like from your home, guys, market is 2 kilometers away, right, from one road. But on this road there are lots of crowd, right? Lots of crowds are there, right? bandwidth is very less of this road. Hardly two bike can travel at a time on this road, right? Again, you have one more road between your house to the market, the clean road, but distance over here is 2.5 kilometer. Here distance is 2 kilometer. Which one you will use to go market from your home? Definitely lower one, right? Because this road is clean. We have more bandwidth here. But according to RIP routing protocol, shortest is always best. This is not true. Am I right? Shortest is always good according to RIP routing protocol. Then slow topology convergence, right? As we have what timers like hold on time is 180 second. So routers are going to remove network information from their table after 180 second. This is again very slow. After that, periodic update after every 30 second, which increase network traffic. And guys, routing by rumors. All routers are dependent on their neighbor. So these are the disadvantage of RIP. That's why we come up with next type of routing protocol, that is link state routing protocol. And before talking about link state routing protocol, let me discuss advanced distance vector routing protocol, that is guys EIGRP. Correct? So now topic is EIGRP, and before starting EIGRP, if you want to see the update message, simply you can capture any link. Like here I can capture this link. Let me capture the link. Are you able to see RIP update message here? Yes. So let me open this update message. See, this is RIP information. Is it visible? Is messages are visible, guys? Layers are visible? Okay. So see, this is RIP information. So guys, in the RIP update message, how many networks are there? 10.1.1.0, 10.1.2.0, 10.1.3.0, 14 network and 24 networks. So router 1 is sending this message to router 3. Right? After that you can see UDP header. In the UDP header, source port is 520. Port number of RIP routing protocol. Destination port is 520. Then we have what? IP protocol. IP header. In the IP header, protocol number is 17. Protocol number of UDP. Source IP is the IP address of exit interface. With the help of this IP address, source IP address only, router 3 will came to know about next hop IP address. What will be the next hop IP address for these all network information? Right? So when router 3, when router 3, God, when router 3 will receive this update message from router number 1, right? It will receive these all network information, and router 3 will see, okay, I am learning this all network information from 13.1.1.1. That means 13.1.1.1 is next hop IP address, right? And then we have what? Layer 2 information, source MAC address and destination MAC address. This is, you can see IPv4 multicast MAC address. Done. Now I have one question for you. Why router 1 is sending only these network information 10, 14 and 24? 10, 14 and 24. Why router 1 is sending only these network information? Why not 20 network, 23 network? Because of speed horizon. Because router 1 is learning this network information from router number 2. Correct? Router is receiving this network information from router number 2. This is why it is not sharing. And if you want to open any network in detail, like I want to open 10.1.1.0/24. See guys, it is sending metric as well, right? Right? Metric is 1. So router 1 is sharing 10 network information 10.1.1.0/24, and it is sharing metric information as well. Metric from me to this network is 0 because this network is directly connected with me. But metric for you will be what? 1. When router 3 will send this network information to router number 2, metric will be what? 2. Right? Router 3 will tell to router 2 metric to this network from me is 1. So metric for this network to you is going to be 2. Right? This is how routers will learn hop count. Yeah. Whenever a router will advertise prefix to their neighbor, it will increment metric by 1. Yes, only 15 metrics are allowed. So if there is one hop, one network, above 15 hop, above 15 router, that will be considered as infinity. That will be considered as infinity. Infinity means route not available. Right? So guys, see in the update message, routers are sending how many information? Network ID, subnet mask, next hop, and metric. If next hop is 0.0.0, that means it is directly connected network. But when router 3 is going to advertise 10 network to router number 2, see when router 1 is advertising 10 network to router number 3, metric is 1. Metric is 1 and next hop IP address is 0.0.0.0, means it is self-advertised prefix. But if you will capture this link, let me do one thing, let me capture this link also. See the difference. Because update messages are going to be same in case of other routing protocol as well, like in EIGRP also. So see, let me open this update message. Router 2 is again sending all 10 network information. This is 20 network information. Actually, router 2 is sending this message to which router? 23.1.1.2. This is update message of router 2. Let me open this message. Right? So we have 10 network information. Router 3 is sending to router number 2. If you will open here, see metric is 2 and next hop is 0.0.0. Next hop is still 0.0.0. How router 2 is going to learn next hop IP address? With the help of source address. Source address in the IP packet is 23.1.1.3. So it will come to know, okay, for this network next hop is 23.3. Right? All network informations are there. Done. This is how update message looks like. Now guys, what will happen if this link will goes down? See, right now router 2 is learning all 20 network from router number 3 as well, from router number 4 as well, and router 1 is learning this network from which router? From router number 4. What will happen if this link will goes down? See, right now this network is reachable via router number 4. If this link will goes down, first router 1 is going to send one update message to router number 3, and it will mark metric infinity for this network. It will mark metric infinity for this network because router 1 is receiving update message from router number 3 also on this interface. And if metric is infinity, that means router 1 is telling to router 3 that, brother, if you have learned this network information via me, then please uninstall it from your table, because now this network is not reachable. First thing. And second thing, if you have any alternate path to reach in this network, then share with me also. Okay. So see, on the in the update message, source is 13.1.1.3. Router 1 is sending this to router 3, right? And how many network informations are there? 10, 14 and 24, right? So router 2 is sending 24 network information to router number 3. Router 1 is sending 24 network information to router number 3. So router 3 is receiving 24 network information on this interface. And whenever this network will goes down, or router 1 will goes down, or this link will goes down, right? Or in other word, you can say whenever router 3 will lose this network information, it will set metric infinity, and then it will send update message to their neighbor. This is what root poisoning. So hope speech horizon is also cleared and route poisoning is also clear to you. Now I am going to remove capturing from here. Any question, guys, in RIP routing protocol? Because now I am going to start EIGRP. Now I am going to start EIGRP. So let me say no router RIP. I have removed the RIP configuration on router number 3 also. Say no router RIP. On router number 2 also say no router RIP. And on router number 4 also I am going to say no router RIP. Then I have removed RIP configuration. So IP protocol. So IP protocol. You can see we don't have any protocol running on the router. So IP protocol. We don't have any protocol. So IP protocol, no. So IP protocol, no. Done. Now next protocol is EIGRP. And guys, EIGRP maintain how many tables? 3 tables. Right. First one is neighbor table. Second one is topology table. Yeah, you can say database or topology table. And third one is routing table. What is the difference between topology table and routing table? In the topology table, it will install all path, and in the routing table, it will install only best path. Done. So EIGRP stands for Enhanced Interior Gateway Routing Protocol. Means it is an IGP protocol. Means it will work within the ES. So guys, first requirement of EIGRP is autonomous system number must be same, right? So to enable EIGRP, you have to configure autonomous system number on router. Let's say you want to configure EIGRP between router 1 and 2, right? So ES number should be same, right? If here ES number is 10, here ES number is 20, then these two routers are not going to become neighbor. And as you know, EIGRP share their routing table with their neighbor only, not with any router like RIP. So before sending routing table, both routers are going to maintain neighborship. And how routers are going to become neighbor? If autonomous system number is same, then only both router will become neighbor. Sometimes we are saying it is a hybrid routing protocol. Why hybrid? Means combination of multiple things, right? So as you know, EIGRP is an advanced distance vector routing protocol, which is combination of link state as well as distance vector routing protocol, right? It will not use distance to calculate metric. Distance means hop count, but still hop count will be forwarded in the EIGRP update message. It will send the hop count information, but it will not use hop count to calculate metric. Next hop is source IP address in the update message. Table, neighbor table, topology table, and routing table. And guys, EIGRP is an open standard routing protocol. Open standard means it is supportable for Cisco devices as well and for non-Cisco devices as well. Even you can configure EIGRP on Nokia devices, on Juniper devices, on any other devices. So earlier EIGRP was Cisco proprietary protocol, but nowadays EIGRP is an open standard protocol. Guys, you know, we have some properties in EIGRP routing protocols which are completely unique from all other routing protocol. This is the reason why we are still using it. Why we are using EIGRP in the real time. So try to understand EIGRP very carefully. It is very important routing protocol for your interview, for the real-time network configuration, for everywhere, right? So basic thing about EIGRP is here you can read like it is an advanced distance vector routing protocol or hybrid routing protocol. It was designed by a Cisco, but nowadays it is open standard. Functionality of EIGRP was converted to open standard in 2013. So in 2013, Cisco has declared this protocol as open standard. EIGRP is used on a router to share routes with other routers within the same autonomous system. And guys, which type of routing protocol it is? It is a classless routing protocol. That means it can support subnetting and VLSM. AD value of EIGRP is 90. Yeah. Yes. Any question? No. So why we have two AD value? Don't worry, we will see it later. And guys, EIGRP is an layer 3 protocol. EIGRP works at layer 3. So tell me at which layer it will generate their messages? At layer 3. Right, we have multiple types of messages in EIGRP. We will see all messages will be generated at layer 3. So EIGRP packet will be directly encapsulated with IP protocol. Right, there is no transport layer header. So EIGRP protocol will generate their message and then it will directly hand over to IP protocol, right? And EIGRP also support automatic summarization as well as manual summarization. So we'll see how we can perform manual summarization in EIGRP, how we can configure automatic summarization. EIGRP also uses hop count but never calculate best path on the basis of hop count. By default, for all routers where EIGRP is running has hop count defined as 100. Means how many hops are supported by EIGRP by default? 100. But we can configure up to 255. Right? So EIGRP can support up to 255 hops, and 255 is guys use for the enterprises, because you are not going to connect 255 routers in a series. Again, it is less for ISP network, but not for enterprises network, right? So these are basic things about EIGRP. Now see how EIGRP works. So I have two routers. First of all, try to understand how two routers will become neighbor. R1, R2. Here IP address is 12.1. Here IP address is 12.2. Behind router 1, I have some network 10.1.1.0/24. And guys, behind router 2, I have one network that is 20.1.1.0/24. Done. On the router 1, you are going to run command router EIGRP and then ES number. Let's say 10. After that, network 12.1.1.0 255.255.255.0. So once you will run these two commands, say this command will allocate memory to EIGRP and this command will enable EIGRP on F0/0. Once I will enable EIGRP on fast Ethernet 0/0, router 1 will start sending hello message from 0/0. It will start sending hello message from 0/0. Which type of message it is? Hello message. So first type of message in EIGRP is hello. What is the use of hello message? It is used to discover neighbor. Clear? Why router 1 is sending hello message? To discover neighbor, right? On which interface? On fast Ethernet 0/0. So once you will enable EIGRP on an interface, router will start discovering neighbor on that interface, right? With the help of hello message, router 1 is actually checking that is there any neighbor available? Is there any neighbor available? Right? So router 1 will be keep sending this hello message after a specific interval of time, that is hello time. So first message in EIGRP is hello message, and if you want to see the content in hello message, guys, again what I can do, I can capture this link and I can enable EIGRP on this port. Right? So go to router number 1, and on router number 1 I am going to enable EIGRP. Say router EIGRP ES number 10, network 13.1.1.0, submit mask 255.255.255.0, like this. Now you can see it has started sending hello message. Yes. Multicast address is, what is the multicast address? 10, right? Means 2.224.0.0.9 is reserved for RIP version 2, and 224.0.0.10 is reserved for EIGRP. Done? Clear? So till now we discussed two types of multicast address. One is reserved for RIP version 2, one is reserved for EIGRP. Now the next thing. See, open any hello message. This is hello message. At which layer? At layer 3. Then guys we have what? IP header, then Ethernet header, then physical layer. Now if you will open this EIGRP hello message, see what informations are there. First information is version. then opcode. Version will define current version of EIGRP protocol, and opcode will define which type of message it is. It is update message or it is a hello message. And guys, opcode of hello message is 5. Opcode of hello message is 5, right? So if I will talk about the content in hello message of EIGRP, hello message. So first information is version. Second information is opcode. Opcode means message type. Message type. Which type of message it is. Third information is checksum, libit, sequence number, acknowledgement number. Third information is autonomous system number. What is autonomous system number? 10. You have defined the autonomous system number on router, right? You have run command router EIGRP 10. So third important information over here is in the hello message is ES number, and ES number is 10. Then guys, key values, parameters, right? Parameters, key values. It is sending key values. Always keep in mind one thing. EIGRP uses key values to calculate metric. EIGRP uses key values to calculate metric, and by default EIGRP uses K1 and K3. If you are thinking that what is key values, so guys, these are link properties like bandwidth, delay, MTU, reliability. Done, right? So by default EIGRP uses two key value, K1 and K3. These two bits are on, rest bits are off. So fourth important information in the hello message is K values. Done. After that, hold on time. Hold on time means when router 2 will receive this hello message, router 2 is going to keep it in their database, in their neighbor table for 15 seconds. If hold on time in the hello message is 20 seconds, then router 2, whatever router will receive this hello message, that router will keep that information for 20 seconds, right? So by default hold on time is 15 seconds. Okay. After that, again, this is not important. This is EIGRP software version, right? So these are informations, important informations inside hello message. Clear? Now, when you will enable EIGRP on router 2, when you will run command router EIGRP ES number 100 and network 12.1.1.0 255.255.255.0, enter. Once you will run this command, what will happen? Router 2 will also enable EIGRP on their interface, on F0/0 interface, let's say, right? So first thing, you already know what first thing router will do. It will join multicast group. So both interfaces going to join one multicast group, that is 224.0.0.10, and this interface will also join this multicast group 224.0.0.10, right? So now guys, router 2 will also start sending hello message from this interface, right? Now both routers are sending their hello message to discover neighbor. When router 1 is going to receive hello message of router 2, it will receive on fast Ethernet 0/0. First of all, it will check what? Layer 2 information. Layer 2 information means destination MAC address. Destination MAC address is multicast address. It will check that this interface is part of that multicast group or not. So yes, this interface is already joined that multicast group. So it will accept that frame at layer 2. It will hand over to layer 3. At layer 3, IP protocol is going to check destination IP. Destination IP is multicast 224.0.0.10. It will again check that this interface is group of this multicast address or not. This interface has joined this multicast group or not. So yes, this interface is already joined that multicast group. So it will accept it, then it will check protocol field. And guys, protocol number of EIGRP is 88. Even in the hello message you can see. Open any hello message and see in the IP header. Protocol number is 88. Right? So IP protocol will come to know that okay, this is a message of EIGRP. So it will remove IP header and then it will hand over to EIGRP protocol. Now EIGRP routing protocol is going to check autonomous system number. If autonomous system number will match, then only it will form neighborship. Right? So guys, in the both hello message, in the hello message of router 1, autonomous system number is 10. In the hello message of router 2, autonomous system number is 10. Right? So router 1 will receive hello message of router 2, it will check autonomous system number is 10 and autonomous system number on me is also 10. Both are same. That means we both can form neighborship. One more thing router 1 will check, that is k values. K values means what k values I am using to calculate metric. K1 and K3. So let me check router 2 is also using same k values to calculate metric or not. So guys, router 2 is also using same k values by default. Both routers are using K1 and K3. Both routers are using K1 and K3. In the hello message of router 2 also K1 and K3. So k values are also matching. That means both router can become neighbor. So router 1 is going to maintain one table. Which table? Neighbor table. Right? And in the neighbor table it will install neighbor information. I have one neighbor whose IP address is 12.1.1.2, which was the source address in the hello message. Right? On which interface? On F0/0. And now router 1 is going to share their routing table with this neighbor. With the help of which message? With the help of update message. Clear? How two routers will become neighbor, guys? In the same way, when router 2 will receive hello message of router 1, it will check autonomous system number and k values. If both are same, then we can form neighborship. Both are same, so it will install that neighbor in their neighbor table. Clear? So see in GNS3, I have capturing here. Right now router 1 is only sending hello message, you can see, to discover the neighbor. But see on router number 1, so IP protocol. Which protocol is running this time? Routing protocol is EIGRP 100. Again we don't have any filtering, right? And k values, it is using K1 and K3, right? As I told you, maximum hop count is by default 100. Don't worry about the variance, don't about the redistribution, these things, leave it for now. How many paths this router can install? By default 4. And right now I am doing routing for this network only. And guys, AD value is 90 and 170. And so IP EIGRP neighbor. This is the command to check neighbor table. Is there any neighbor available? No. Why? Because EIGRP is not enabled on router number 3. So now on router number 3, I am going to enable EIGRP. Router EIGRP AS number same AS number, then network 13.1.1.0 255.255.255.0. Now see, router 2 have also sent their hello message, right? After that, router 1 is sending what? Update message. Update message. And guys, EIGRP is a reliable protocol. So you can see both routers are sending acknowledgement as well after receiving update message. Not all messages of EIGRP are reliable. Few messages are reliable, like update message is reliable. Hello message is not reliable. So routers are not going to share acknowledgement for hello message. But whenever router will receive update message, it will acknowledge to their neighbor, because update message is the reliable message. Now if you are thinking that if EIGRP is layer 3 protocol, then how it can be reliable protocol? Because transport layer decide reliable or and unreliable. If protocol is TCP, that means it is reliable. If protocol is UDP, that means it is unreliable. But it is a network layer protocol, then how it can be reliable? So guys, it is possible by using any external protocol. So actually EIGRP is a protocol which uses RTP protocol, another protocol for reliability. RTP, right? Don't worry, we will discuss this protocol later for reliability. So next message of EIGRP is update message. And what is the use of update message? Update message is used to share network information, right? Update message, it is used to share network information. Clear? Till now I have discussed two types of message in EIGRP. Now guys, see, earlier router 1 was sending hello message. In all previous hello message you can see source IP is 13.1. Where is the first hello message of router 3? Here is the first hello message, source 13.1.1.3, right? And after that, after receiving hello message from router number 3, router 1 have sent what? Update message. This is first update message. If you will open this update message, you can see, is there any network information in the update message? Is there any network information? No. What informations are there in the update message? Autonomous system number, sequence number, version, and opcode. Opcode is 1. So if opcode value is 1, that means it is an update message. If opcode value is 5, that means it is an hello message, right? Anyone can ask you these small types of questions like what is opcode? So opcode is nothing but types of message in EIGRP. Types of message in EIGRP, right? Opcode value of hello message is 5, opcode value of update message is 1. How many types of messages we have in EIGRP? For all types of EIGRP messages, we have opcode value, one for hello message, one for update message, one for query message, one for reply message. Done. And guys, we have multiple types of update message. Actually, you can say we have two types of update message. One is null update, right? One is null update, which is used to check bidirectional connectivity. And this is null update message. You can see in this update message, we are not sharing network information, right? Only it is sending what? Sequence number, right? So after receiving hello message from router number 3, router 1 have sent update message, and then router 1 update message. See, router 1 have not received the acknowledgement for the update message, so it have sent update message again, same update message with sequence number 2. Done. Now this is the update message of router 3. Router 3 is sending the update message, right? After receiving the update message from router number 3, and here you can see sequence number is 1. This is first update message of router 3. And again, router 3 is also not sharing network information. Both router have exchanged the null update message. Now both are going to acknowledge, right? Which type of message it is? Hello message. Close the hello message. Here is the actual update message of router 1. See guys, in the actual update message, router 1 is still not sharing any network information. The reason, till now we didn't enabled EIGRP on LAN interface. So right now, till now we have discussed the neighborship in EIGRP, how two routers are going to become neighbor in EIGRP. Right now I am going to advertise LAN network information in EIGRP. Is it clear? How neighbor, how two routers will become neighbor? With the help of hello message, both routers will send hello message to discover neighbor, and hello message carry multiple information like version, opcode, AS number and K values. And guys, what is the neighborship parameter? AS value and K values, right? AS number should be same, K values should be same. Then only two routers can become neighbor in EIGRP. Done? Then only two routers can become neighbor in EIGRP. And K1 is what? Bandwidth. K1 is bandwidth. K2 is load. K3 is delay. K4 is reliability. K5 is MTU. Right? Like if you want to tell to router, please use K3 also. So you can configure the router. But guys, now on router number 1, you can verify that we have neighborship or not. And you can see the log message as well. We have EIGRP neighborship, new adjacency, and you can run command show IP EIGRP neighbor. So who is neighbor of this router? 13.1.1.3, right? On which interface? 0/0. This is nothing but serial number, right? Hold on. So this router is going to hold this neighbor for next 11 seconds, but after 5 seconds it will receive one again hello message. Hello time is 5 seconds by default, hold on time is 15 seconds. So after each 5 seconds it will reset the timer, right? Up time, till when this neighbor is up? Till 7 minutes 28 seconds this neighbor is up. Don't worry about the RTO time, SRTT time, Q count and sequence number. Sequence number is the latest sequence number from this neighbor is 3, right? So you can see hold on time is changing, right? 14 second, then 12 second, then 10 second, again 15 second, right? So by default hello message is, hello time is 5 second. Debug IP EIGRP debug EIGRP, and then what we can do, we can say packets and hello. Like this we can debug, we can enable debugging for EIGRP hello message. So you can see after each 5 seconds it is sending hello message. Done. And this is by default configuration of K values, right? So with the help of metric wait command we can tell to router that which K values you need to use. Like on router number 1, router EIGRP S number 10, do and all. Let me disable the debugging. So right now I am in EIGRP mode, router EIGRP 10, and here I can say what? Metric wait. Now quality of service, this is for quality of service, it will be always 0. Now it is asking K values. K1 means bandwidth. Should I use it or not? Yes. K2 load, no, don't use K2. K3 yes. K4 no. K5 no. right? So this command is by default enabled. Guys, if I will change, like here I am saying please use K2 also, K3 also, not K4, not K5. Now what will happen? Neighborship will goes down. Why neighborship is down? Because of K value mismatch. Neighborship requirement is K value should be same, right? So IP EIGRP neighbor. Now you can see neighborship is down. So how you can troubleshoot it? How you will troubleshoot neighborship between router 1 and router 2? You are going to check what? K values. And even you can see the log message now. You are getting log message, K value mismatch. This is why neighbor is down. Right? So simply I can remove this command, router EIGRP number 10, and say no to this command. Let me say default. Again EIGRP neighborship will come up. Now you can see, right? So IP EIGRP neighbor. Now if I will configure different ES number here, router EIGRP ES number 10 is, sorry, I'm going to remove EIGRP ES number 10 from here, and I'm going to configure what 20. Router EIGRP ES number 20 and say network 13.1.1.0 255.255.255.0. Do you think EIGRP neighborship will come up? Will EIGRP neighborship come up? No. So IP EIGRP neighbor. So now guys, engineer have configured EIGRP between router 1 and router 2 and neighborship is down. How you are going to troubleshoot it? You will check ES number. Simply you can enable the debugging as well. Debug EIGRP packets hello, and on router number 3 also debug EIGRP packets hello, right? Let me check, both are sending hello message. Yes. What is the ES number over here? 20. What is the ES number on router number 3? 10. Oh my god, ES number is mismatch. So we need to correct it. Either I can configure 10 on router number 1, or I can configure 20 on router number 3. Say no router EIGRP ES number 10, no router EIGRP ES number 10, and now I'm going to say EIGRP router EIGRP ES number 20, network 13.1.1.0. Now again EIGRP neighborship will come up. You can see. So IP EIGRP neighbor. We have neighborship. Yes or no? So always keep in mind the parameters of EIGRP neighborship, guys. ES value and K values must match to become neighbor, right? So whenever I am asking to you how two routers can become neighbor in EIGRP, always say K values and autonomous system number should be same. In the hello packet, both router will tell each other what K values they are using for the metric calculation and their ES number. By default K values K1 and K3. And guys, now question is how EIGRP is going to calculate metric. Like router 1, router 2. Then I have one switch here. Switch. Switch R1 and R2. IP address 12.1 F0/0. IP address 12.2 F0/0. Here network is 192.168.10.0/24. Here IP address is 10.1, let's say, and this interface is F0/1, right? So on router number 1, you are going to run few commands to enable EIGRP. First is router EIGRP ES number 10. then network 12.1.1.0 and network 192.168.10.0. What will happen? Both interface will join the multicast group. Here you can verify the multicast group as well. So IP interface F0/0. So you can see this interface have joined this multicast group. Done. 224.0.0.10. Now how routers are going to calculate metric in case of EIGRP? So guys, first thing is, first of all, both router will become neighbor. Then router 1 is going to advertise 192 network to router number 2, and it will use one formula to calculate metric, and formula is this one. 256, or you can say like this, 10 raised to power 7 upon list bandwidth plus total delay upon 10 and whole multiply by 256. Whole multiply by 256. So how router 1 is going to calculate metric for this network? It will use this formula, 10 raised to power 7 upon list bandwidth of fast Ethernet link, bandwidth in kbps. So guys, bandwidth for fast Ethernet link is, here you can see which link I am using, fast Ethernet, right? Even you can see the bandwidth here as well in the note. Bandwidth for Ethernet is 10,000 kbps, bandwidth for fast Ethernet is 1 lakh kbps, right? Or you can check in the command. So interface F0/0, I can say include bandwidth. So bandwidth is 1 lakh kbps, right? 10 raised to power 5. So bandwidth is 10 raised to power 5 plus total delay. Guys, delay of this interface is 1000, right? 1000 UCOS, right? Means 100 millisecond. So 100 by 10, 100 by 10 and whole multiply by 256. Here I will get 100 plus 10 whole multiply by 256. What value I will get? 110 multiply by 256. What value I will get here? Can anyone calculate, guys? Please calculate. 110 multiply by 256. What is the metric on fast Ethernet 0/0? 28160, right? So now this is your question for tomorrow. You need to find metric for 192.168.10.0 network on router number 2. When router 1 will advertise this network to router number 2 with the help of update message, it will share this network 192.168.10.0/24. It will send k values, right? Like bandwidth of receiving interface is 100 mbps, means 1 lakh kbps. Then it will send delay is 10. Now when router 2 will receive this network information, router 2 is going to calculate metric. How? It will use same formula, 10 raised to power 10. The least metric, it will compare their own bandwidth and bandwidth which is coming in update. So bandwidth which is coming in update is 100 Mbps, and bandwidth of my interface is also 100 Mbps. Both are same, so it will use 100, means 10 raised to power 5, 100 Mbps. If here link is Ethernet, then bandwidth is going to be 10,000, right? So whenever a router will receive a network information in EIGRP, it will compare bandwidth, right? Bandwidth which is coming in update and bandwidth of their receiving interface. It will choose least bandwidth, plus formula is plus total delay. So delay which is coming in update is 10, and delay of my interface is also 10, right? Or delay which is coming in the update message is 100, and delay of my interface is also 100. So total delay is 200 upon 10, and whole multiply by 256. Whatever value you will get, that will be metric on router number 2 for this network. When router 2 will advertise it to router number 3, again router 2 is going to share network information, bandwidth and delay. Don't think their router are going to share metric information. No, no, no. Routers will share bandwidth and delay information, k values. And all receiving routers are going to calculate metric by their own self. Right? So guys, what you can do, you can design a simple topology here in the GNS3. See the bandwidth and delay of 4 is type of interface, like for 10 gig, 4 gig, for fast Ethernet, for loopback interface. Design one topology like this: R1, R2 and R3. Then take one switch here, or even you can use loopback interface instead of connecting switch. All links are fast Ethernet link. You already know the bandwidth and delay of fast Ethernet link. Between routers, you can use 12 and 23 networks. And here, let's suppose I am using 192.168.10.0/24 network, and you need to calculate metric for this network on all router, on router number 1 also, on router number 2 also, and router number 3 also. First you will calculate metric by yourself. After that you are going to verify it. Now I am expecting that you can enable EIGRP protocol between all routers. It is simple. And then verify the metric. Here you can use subnet 12.1.1.0/24. Here subnet is 23.1.1.0/24, right? And guys, please share your answer in the group. Like metric on router 1 is 28160, metric on router 2 is this one, metric on router 3 is this one. What will be the metric on each router? For which network? For this network only. You don't need to calculate metric for 12 network or for 23 network. Clear? Can you configure? Can you calculate the metric? Yes. Even I am sending this topology to you. If you don't want to design it, simply you can open this topology in your GNS3, EIGRP. First you will configure the IP, then you are going to configure EIGRP, then calculate the metric. Formula is very simple: 10 raised to power 7 upon least bandwidth plus total delay upon 10 and whole multiply by 256. This is the formula to calculate metric in EIGRP. So see guys, EIGRP is using bandwidth and delay, and even we have more parameters. By default EIGRP is using K1 and K3 value to calculate metric, but if you want you can use all K values like load also, MTU also, reliability also. Yes or no? So this is your lab for tomorrow. If you guys will calculate metric by yourself, then we'll see the next topics in EIGRP. Otherwise, tomorrow we will discuss metric calculation again here. Okay? Any question? Anybody? Yeah, go ahead. Yes, bro. Yes, you are audible. After each 5 seconds. See, there are two use of hello message. Till now we discussed one use to discover the neighbor. You know, second use of hello message is keep alive. Keep alive means to check neighbor is alive or not. To check neighbor is alive or not. So both router are keep sending hello message with each other. Now if you are thinking that then what is the difference, sir, from the RIP routing protocol? Because RIP is also sending periodic message, it is also sending periodic message. Bro, there is huge difference. This time router is sending hello message periodically. Size of hello message is very less as compared to update message, because update message is going to carry all network information, but hello message is going to carry only few information like ES number, version, opcode and key values, right? Update message is not periodic message in EIGRP. Update message is trigger message. So it will send update message for the first time. After that, whenever change will occur, right? So hello message is again periodic messages in EIGRP, right? And there are two use of hello message. First time router will send hello message to discover the neighbor, and after discovering the neighbor, it will be keep checking that my neighbor is alive or not. So second use is keep alive. And guys, hold on time is 15 seconds. That means let's suppose router 2 is not receiving any hello message. If router 2 will not receive a consecutive 3 hello message, then it will remove the neighbor from the neighbor table, right? If it will not receive 3 consecutive hello message, then it will remove the neighbor, right? But let's suppose because of congestion on the link, it have not received second hello message, it have received one hello message, then it have not received the hello message. So hold on timer will become 5 seconds. After that again router 1 will send hello message, it will reset the timer. But if it will not receive 3 message, then hold on timer will become 0. Once hold on timer will become 0, it will flush the entry, right? So this is why I have discussed RIP routing protocol guys here, because now it is easy for me to teach you EIGRP. Done. Any other question? Okay. Right. Otherwise neighborship will not come up. Yes or no? So whatever, if you want to configure EIGRP between R1, R2, R3, ES number should be same and K values should be same on all routers, right? So let me finish OSPF in next 2 to 3 class, then we will move to OSPF routing protocol, right? See, there are many more theory like load balancing, dual algorithm, how or EIGRP is going to calculate best path, then types of messages. How many types of message I have? Hello message, update message, query message, reply message and acknowledgement message, right? So you need to learn what is the opcode for hello, update, query, reply, acknowledgement. Definitely you don't need to keep it in mind, but you should have at least this knowledge, like opcode is message type, right? Then here also you can see content of hello message, version, opcode, checksum, sequence number, acknowledgement number, key values, hold on time, iOS version, and authentication. Even in EIGRP, we will see the authentication configuration. Here you can read EIGRP neighborship parameter. Like as I told you, AS number must match. Subnet mask also must match. Like between router 1 and router 2, you have configured the EIGRP. So guys, in the hello message, both router will share subnet mask as well. Subnet mask 255.255.255.0. In the hello message of router 2 also subnet mask is 255.255.255.0. So this subnet mask could also match, right? If subnet mask is different, then these two routers cannot communicate with each other, right? If these two routers cannot communicate with each other, that means definitely we cannot run any routing protocol. So subnet mask should be matched. That is the requirement of connectivity between two router. Then metric weight should be match. If you have configured the authentication, then authentication should also match. Like if you have configured the password, so definitely password should match. EIGRP does not have its authentication parameter. It will take help router keychain features. We will discuss it in the authentication part. Don't worry. How to configure authentication on EIGRP? Command to configure EIGRP. See how to change the hello time, how to change the hold on time. By default, hello time is 5 seconds and hold on time is 15 seconds, but you can change it. Then as I told you, it is a reliable protocol. So it uses RTP protocol for reliability, reliable transport protocol, right? So EIGRP is using third party protocol for the reliability. And in EIGRP, we have how many types of message? 5 type of message: hello message, update message, then query message, then guys reply message, and acknowledgement message. So out of these 5 messages, these 3 messages are reliable. These 3 messages are reliable: update, query, and reliable. Reply. Right, so we will see how RTP protocol work, don't worry. Then guys, adjacency, how two router will become neighbor in EIGRP. So you can see the diagram, both are sending their hello message. In their hello message, these all parameter will match, so these two router will become neighbor. See the all steps as well. Like in the first step, it will send this message. Second, third step, 4, 5, 6, 7, 8. Don't worry, we are going to discuss these messages. So we have many more concepts in EIGRP than query message, split horizon. You already know the split horizon. You already know the route poisoning. So we are not going to discuss it again. Split horizon with route reverse. This is new for you. Then types of neighbor in EIGRP. Till now we discussed dynamic neighborship, right? Both our routers are forming dynamic neighborship, but in EIGRP we can configure a static neighborship as well. Like I can say to router that your neighbor is 12.1.1.2. Okay, so don't worry about these topics. And this is the unique feature of EIGRP. Only EIGRP has this feature, unequal cost load balancing. There is guys no any other protocol who can perform unequal cost load balancing. Unequal cost load balancing means if metric it is different, then also we can perform load balancing. By default, router perform load balancing if all 3 parameters will match, like prefix length, AD value, and metric. But in EIGRP, you have a features to perform unequal cost load balancing. Okay, so don't worry about these topics. We'll see it in next class. That's all for today. Now, if you have any question, please ask. Any question to anybody? All